Okay, on page 343 we have word problem number 4, which tells us that there's two numbers that we're supposed to find such that their sum is 20, and the sum of their squares is something that we want to minimize. We want to make it as small as possible. So I'm going to make y represent the sum of their squares, and I'm going to make x be one of the numbers. So one of the numbers will be x, and then the other one will be 20 minus x. So I can say that the sum of their squares that I want to minimize, y, is equal to the sum of their two squares. So x squared plus 20 minus x squared. So here's the two numbers, x and 20 minus x, and I want to minimize this sum of the two squares. So simplifying this, I get, this is, when I FOIL out 20 minus x times 20 minus x, 400 minus 20x minus 20x minus 40x plus x squared, combining my x squareds. Okay, so I can see this is a function, a parabola that opens up, and that's why I'm trying to minimize their squares. So that vertex is going to have the coordinates of, well, one of the numbers x, and then y, the sum of their squares. So let's get this in vertex form. Pull out the 2, squared minus 20x plus blank to complete the square, plus 400 minus blank. Okay, whatever I add here, I'm going to subtract out here, and remember I'm adding 2 times that number. So y equals half of negative 20 is negative 10. When I square negative 10, I get 100. So I just added 200, so I have to subtract out 200. So 400 minus 200 is 200. So I get a vertex here of 10, 200. This is x and this is y, meaning this is the sum of the two numbers' squares, and one of the numbers is 10, so x is 10. Then the other number, which is 20 minus x, is also 10, and the sum of those squares, 10 squared plus 10 squared, is 200, 100 plus 100. So that makes sense of this. And if you took any other numbers that added together to be 20 and you added up the sum of their squares, they would not be as low as 200. They would be bigger. So that's what that vertex represents. And that's it.